Hey everyone, today I would like to discuss with you the vehicle indicator lights and gauges. Also, I would like to explain to you the oil pressure indicator, engine temperature warning lights, charge indicator lights, brake warning lights, oil pressure gauge, engine temperature gauge, and fuel level gauge. But first off, I would like to tell you about the learning objectives. After you have watched studied and practiced the contents of this video, you should be able to explain the operation of oil pressure indicator and charge indicator lights. Describe the operation of a bimetallic gauge. Explain the purpose and operation of the instrument voltage limiter. And describe the proper ammeter and voltmeter connections in an electrical circuit. When you understand normal indicator light and gauge operation, you are able to diagnose problems in these circuits. Technicians must be able to quickly and accurately diagnose whether the defect is in the indicator light or gauge itself or in the system that the indicator light or gauge is monitoring. The sending unit for the oil pressure indicator light is an on-off switch with a set of normally closed contacts. This sending unit is usually threaded into an opening in the main oil gallery of the engine block. Normally closed contacts are closed with no pressure supplied to the unit and opened when pressure is supplied to the unit. Full pressure from the lubrication system is supplied to the sending unit. If less than 3 psi or 20.6 kilopascal oil pressure is supplied to the oil sending unit, the contacts in this unit are closed. Under this condition, current flows through the oil pressure indicator light and the sending unit contacts to the ground and the light is on. When the engine is started, oil pressure is supplied to the diaphragm in the oil sending unit. If the oil pressure exceeds 3 psi or 20.6 kilopascal, the sending unit contacts are forced open and the indicator light goes out. The sending unit for the engine temperature warning light contains a bimetallic strip and a set of normally open contacts. Normally open contacts remain in the open position until they are acted upon by temperature or pressure. When the engine temperature is below a specific temperature, the contacts in the temperature setting unit remain open and the temperature warning light remains off. If the coolant temperature increases to a specific overheated condition, the metallic strip bends and closes the contacts in the sending unit. As long as the overheated condition is present, the sending unit contacts remain closed and the temperature warning light is on. Many temperature warning lights have a proving circuit in the ignition switch. When the ignition switch is in the start position, the proving circuit contacts in the ignition switch ground the temperature warning light. This illuminates the temperature warning light while cranking the engine and proves that the temperature warning light bulb is operating. Some charge indicator lights have a resistor connected in parallel with the bulb. When the ignition switch is turned on, current flows through the charge indicator bulb and parallel resistor to one of the alternator terminals. This current flows through the alternator number 1 terminal to the alternator field coil and electronic voltage regulator to ground, and the charge indicator light is on. Once the engine starts, approximately 14.2 volts are supplied from the alternator battery terminal to the battery and electrical system. This same voltage is also supplied from the alternator stator windings through the diode trio to the field coil and to the number 1 alternator terminal. Because equal voltage is supplied to both sides of the charge indicator bulb, these lights remains off. The red brake warning light in the instrument panel is connected to a switch in the combination brake valve. The combination brake also contains two hydraulic valves, the mirroring valve and the proportioning valve. Pressure from each master cylinder piston is applied to opposite ends of the combination valve piston that operates the brake warning light. If the master cylinder fluid level is satisfactory and both master cylinder pistons supply the same pressure, the piston in the brake warning light circuit remains centered. Under this condition, the brake warning switch is open and the warning light is off. If a fluid leak occurs and pressure from one master cylinder piston is low, the brake warning light piston moves toward the pressure side of the piston. This action grounds the brake warning light bulb through the switch and the bulb is illuminated. This circuit also is a prove out circuit for the bulb check when cranking. On many vehicles, the red brake warning light is also illuminated if the parking brake is applied. The brake pad sensors detect a worn lining or the brake fluid level is low. Various types of gauges are used in instrument panels. Each type of gauge has different operating principles, and technicians must understand gauge operation to accurately diagnose and service each type of gauge and its related circuit. Most vehicles prior to 1980 are equipped with bimetallic gauges. In this type of gauge, the needle is linked to a bimetallic strip. A bimetallic strip contains two different metals fused together. As a bimetallic strip is heated, this metal expands at different rates and cause the strip to bend. When the strip is heated, it pushes the needle across the gauge scale. A heating coil surrounds the bimetallic strip, and the amount of heat supplied to the strip depends on the current flow through the heating coil. This gauge sending unit contains a variable resistor that controls the current flow through the heating coil. Bimetallic gauges have voltage limiters in their circuits to operate properly. Almost all of this type of gauge operates on 5 volts. Bimetallic gauges most commonly were used as fuel and temperature gauges. Some gauges contain a low coil and a high coil. The gauge needle is pivoted between the two coils and a permanent magnet is mounted on the needle. When the ignition switch is turned on, voltage is supplied between the two coils. The low coil is grounded and the high coil is connected to the sending unit. If the sending unit has high resistance, most of the current flows through the low coil to ground because this coil has lower resistance than the high coil and the sending unit. The magnetic field of the low coil attracts the magnet on the needle and moves the needle to the low position. When the sending unit has low resistance, most of the current flows through the high coil and the sending unit. Under this condition, the magnetic field of the high coil attracts the pointer magnet, so the pointer moves to the high position. In some balancing coil gauges, voltage is supplied to the low or empty coil, and the sending unit is connected between the empty coil and the full coil. The full coil is grounded. For instance, when the fuel level is low in the tank, the sending unit has low resistance. Under this condition, current flows through the empty coil and the sending unit to ground, and the magnetic field of the empty coil attracts the needle near the empty position. If the fuel level in the tank is high, the sending unit has high resistance. Under this condition, the current flows through the empty coil and the full coil to the ground. Since the full coil has more coils of wire, it develops the stronger magnetic field and attracts the needle near the full position. A common test for this type of gauge was to remove the power lead from the sending unit. This would send the gauge to either high or low, and then ground the wire sending the gauge to the opposite indicator. This test would confirm that the gauge and its wiring were okay, and then the tech would test the sending unit. The sender for an oil pressure gauge contains a diaphragm and a variable resistor. Engine oil pressure is supplied to the sending unit diaphragm. As the engine oil pressure increases, the sending unit diaphragm moves upward and the contact arm slides along the resistor. An increase in oil pressure reduces sending unit resistance, and a decrease in oil pressure increases sending unit resistance. The change in resistance would affect the amount of voltage returned to the gauge in the same way that the fuel gauge system works. A second type of oil gauge is a mechanical system. This type of gauge, oil is piped to the gauge itself, and the pressure itself works similarly to any other air or fluid pressure gauge. The temperature sending unit is threaded into the opening in the cooling system. This sending unit is often mounted in the top of the intake manifold or in the cylinder head. The lower end of the sending unit is in contact with the engine coolant. The sending unit for most temperature gauges contains a resistor disc called a thermistor. A thermistor is a special resistor that changes resistance in relation to temperature. At low temperatures, the thermistor has high resistance, and as the coolant temperature increases, the resistance decreases. This would cause the balancing coil gauge to read hot or cool depending on resistance at the sender. The fuel level gauge contains a float mounted on an arm attached to the gauge. The float moves up and down with the level in the tank. As the float moves up and down, it moves a sliding contact on a variable resistor in the sending unit. High fuel level in the tank results in low sending unit resistance, and a low fuel level increases sending unit resistance. The fuel sending unit that is connected between the empty and full coils on a balancing coil fuel gauge operates the opposite way compared to the sending unit for a bimetallic gauge. The sending unit for this type of balancing coil gauge has high resistance when the fuel level in the tank is high. An instrument voltage limiter may be connected to bimetallic gauges. This limiter contains a set of contacts mounted on a bimetallic strip. The voltage supply to the gauges is connected through the limiter contacts. A heater coil surrounds the bimetallic strip, and this heating coil is connected to ground on the limiter. The instrument voltage limiter must be grounded on the instrument panel, and this panel must have a satisfactory ground connection to the battery. If the instrument voltage limiter does not have a satisfactory ground, the limiter contacts remain closed, and this action supplies 12 volts to the gauges. This voltage will damage the gauges very quickly. When the ignition switch is turned on, voltage is supplied through the limiter contacts to the gauges. Current also flows through the heating coil to ground. The heating coil heats the bimetallic strip very quickly, and the limiter contacts open the circuit to the gauges and also to the heating coil. The bimetallic strip coils quickly and the contacts close. The voltage limiter supplies a pulsating 5 volts to the gauges regarding of the input voltage, and this provides more stable gauge operation. That's it for today's topics. I hope you like the presentations. And if you do, please subscribe, like, and share. And thank you for watching.